Okay, hello. You are looking at a Jamboard to help you or your chemistry students solve molecular orbital diagram problems. So, whether you want to build one of these yourself or buy mine from Teachers Pay Teachers, here's the way you can do it to save yourself a lot of time while you're teaching this concept. So, here's what I've made. So starting up here at the top, we've got a space for you to write the formula. So let's say we were going to do nitrogen. So I go over here and I click the T for text box, and I'll click in here and I'll type an N, and then to actually make it look like a chemical formula, I'll type a new text box. I'll come up here to where it says display. I'll change the font and I'll make it a little smaller. Type my 2, and then I'll click it in. I'll just drag it down here so that it looks right. Each nitrogen has 5 valence electrons, and nitrogen overall is number 7 on the periodic table. So fill in your total electrons and fill in your valence electrons. I've put both blocks so that you have the choice of going all the way up and doing the whole molecular orbital diagram, or only doing the diagram for the valence electrons. Do whatever works for you. So total electrons, we got 14. Valence electrons, we've got 10, because each nitrogen has 5. So here we'll click the text box again, and there you go, 10 valence electrons. What I like to do while I do these is keep a total electron count, so I don't have to keep counting. So what I'll do is I'll duplicate this 14 and I'll put it over here under electron count, so that every time I put electrons on the screen, I can go over and adjust it. We have our energy arrow indicating that energy increases as you go up. And then I've got the molecular orbitals in order from lowest energy up to highest energy in the 1s, 2s, and 2p. And usually, if you're teaching an intro chem class, or if you're teaching like AP chem, or you're teaching chem, say, to first year college students, this is all the further you're going to go with molecular orbitals. Now, I'm going to put the various electrons for nitrogen in the different levels. And I'm going to do that using arrows like you would on an atomic orbital diagram of the kind that you usually go over while you're going over electron configurations. So we'll start by filling in the sigma 1s. I'll click on one of the up pointing arrows, I'll drag it, and I'll click on one of the down pointing arrows and I'll drag it over. There you go. 2 electrons in the 1s, it's done. You can click and drag, or you can click the kind of arrow you want and then click the 3 dots here like this, and you'll get a menu. You can hit duplicate and make another one, or if you want to delete one you have, you can hit delete. Whatever works for you. So there you go. I put 2 electrons in the sigma 1s. So I'll go over here, I'll click edit, I'll go down to a new row, and I'll type my new count, which is 12. Because I used 2 of them. Next, let's put 2 electrons in the sigma star 1s. So I'll go over here, I'll click an up arrow. The up pointing arrow represents 1 spin, and the down pointing arrow represents another spin. So there you are, 2 more electrons used. I'll go back over to the counter, I'll hit edit, and I'll take the count down to 10. Now, if you want, you could have these 4 electrons filled in already when you start this. Up to you. I prefer to do the whole thing, at least initially with my students, so that they see the idea of filling in all the electrons in the molecule. It seems to work better for most of them. Do it however works for you. Now, we filled in the 1s. We're into level 2. Notice that I've got two different versions of level 2. That's because the version of this you're going to use depends on the molecule you're working with. So over here on the left, this is the energy levels in order for Li2, Be2, B2, C2, and N2. And then over here on the right, we have O2 and F2. Since I got N2, I'm going to use the one on the left. So let's put in 2 more electrons. Here's an up arrow. And here's a down arrow. And again, let's go back over to my counter. Now we're at 8. Still have electrons, so now I'll go up to sigma star 2s. Grab an up arrow, grab a down arrow. Try not to click and drag or you'll end up spinning them. Okay, I used 2 more. We'll go back over to the counter, reduce it to 6. Now we're in the pi 2p. As we fill in the pi 2p, we got to keep the rules in mind so that before we fill up any one of these pi 2p's, we're going to put 1 electron in each. So I'll put 1 up arrow in each. You can go down arrows first if you want, it doesn't really matter. I prefer up arrows so that the students do the same way every time. And then once I do that, I put 1 down arrow in each. So there you go, I used 4 electrons. Let's go back to my counter, take it down to 2. And then next level is sigma 2p. So grab an up arrow, grab a down arrow, and there it is. Our diagram is done. So I'll go over here, I'll put a 0. All the valence electrons are used. So we can see the molecular orbital diagram right there. All that's left is to calculate bond order. I got the bond order box here in the middle of the page. There's the formula. The number of electrons in bonding orbitals minus the number in anti-bonding orbitals divided by 2. Okay, so again, let's do another text box. And let's count bonding orbital electrons. So we got anything without the star. So there's 2 in the sigma 2p. There's 4 in the pi 2p, that makes 6. There's 2 in the sigma 2s, that makes 8. And there's 2 in the sigma 1s, that makes 10. So there we go, 10. Slide it over a little bit so it looks nice. Okay, now, antibonding. All right, well, we got 2 in the sigma star 2s and 2 in the sigma star 1s. So that's a total of 4. You can make another text box or you could just add them in here. So I got 10 minus 4 divided by 2. 10 minus 4 is 6. 6 divided by 2 is 3. So we'll make one more text box here to fill in the bond order. We got a bond order of 3. The bond order of 3 suggests that this is a triple bond in N2, which agrees with what's observed. Nitrogen bonds to itself. It's going to share 3 pairs of electrons, make a triple bond. So it agrees with the predictions in atomic orbitals and Lewis structures and molecular orbitals here as well. So there you go. This is how you can use a Jamboard to save yourself some time showing students how to do molecular orbitals. And if you want to buy mine, great. If not, you can at least see how to make your own. Now, if you want mine, the majority of this is a background. So if I try to click anywhere like where it says energy or where it says formula, it's not going to move. The only things in here that can actually be moved are text boxes I make myself or these arrows, which are already pre-made. There you go. Thank you for watching.